Welcome to part 4 in this series of buying batteries from China. In part 4, we're going to be looking at battery capacity tests for importers of electronic products. So let's have a look at battery capacity. What is battery capacity? Well, in a nutshell, battery capacity is a measure of the energy it can store. When you test for capacity, you're looking at the battery's ability to deliver a specified amount of current at a constant rate to a specified end voltage for a specified time. We determine capacity by filling the battery with energy and then seeing how long it takes to empty the energy. Now, the main reasons for testing, well, you determine where the battery is on its predictable life curve. You know when to replace a battery, and you can locate weak cells and faulty intercell connections. So conducting an inspection. So let's have a look at what the test entails. To perform a load test, you subject the battery to a constant current load while measuring the string overall voltage and the individual cell voltages. You compare the time it takes for the voltage to decline to a predetermined level with the manufacturer's rated time. Then you use the following equation to grade your capacity so the results are more meaningful. So that equation is capacity equals the actual time divided by the rated time times 100. To preserve battery life as much as possible, use a higher discharge rate to give you a shorter test time. What end voltage you should use depends on the test equipment available and whether you test the batteries online or offline. Select the current level you are maintaining from the manufacturer's table or load test curves. So there are 4 different types of test. 1. There's a full string test offline using load banks. This applies to facilities such as power plants where you can't use an actual load. 2, which is a full string test online using load banks. A typical application is a substation testing. 3, single cell test online. This applies frequently to central office testing. And 4, which is the rundown test using actual load. You can supplement the actual load with a load bank to control the desired discharge rate. So let's have a look at the 4 steps. So each test requires 4 steps. 1. The pre-test. Ensure hardware is calibrated and working. Connect all test leads and load modules. Program test parameters. Prepare plan of action in case a cell fails or failures. Measure ambient or electrolyte temperature and compensate the load to be applied using the applicable IEEE standard. 2. The actual testing. Verify all voltage readings are correct, then disconnect charger and start testing. Within the first 10 to 20 seconds, verify the test current is correct. Then look at low cell voltages. If a single cell voltage is more than 30 millivolts below all of the others, it requires investigation. Identify the problem source, cell or intercell, and then decide if you must interrupt the test. The middle of the test is typically uneventful. Towards the end of the test, cell voltages are dropping fast and you must watch them closely. Once cell voltage is below 1.75 volts, it will drop rapidly. At this point, stop the test before it can go into reversal. If a cell fails early in the test, you can momentarily halt the test and bypass that cell. You can halt the test only for 10% of the total test time, or 6 minutes, whichever is shorter. You normally halt a load test manually or automatically for one of the following reasons. 1. Overall voltage reached the end voltage. 2. At least one cell is failing. Or 3. Test time exceeds the value equal to 100% capacity battery. Step 3. Post-test. Verify the load is properly disconnected. Reconnect the charger and verify charge current is correct and all cell voltages are recovering normally. Disconnect all load test cables. Disconnect all sense leads. Print out the test report. And step 4 is analyze the data. So we need to calculate the battery capacity. If capacity exceeds 80%, the battery passed. Otherwise, it failed. Evaluate individual cells for replacement. As with all tests, battery load testing gives you a snapshot of what you see now. It does not certify the batteries will perform as expected for the next 12 months, regardless of improper maintenance. So battery performance testing. Let's have a look at testing battery capacity. For any sort of accuracy, you need to discharge the battery to an endpoint and measure capacity. There are other methods such as measuring the change in voltage over a given time under a given load and trying to assess where you are on a discharge curve, but this is difficult to get right and needs experience and a degree of luck. Measuring discharge time is a lot easier. A discharge resistor that takes at least 1 hour to discharge should be used. You could use a motor or a lamp or a camera, for example, but a resistor does have some advantages. So let's have a look at the minimum value for that resistor. So on the right hand side here we can see how we calculate that out. So it's the cells in the battery times 4000 divided by the milliamp hours. For example, if you have one cell battery, which is the voltage of around 4.2 volts of 1500 milliamp capacity, then the resistor equals cells times 4000 divided by milliamps, which equals 1 in this case, times 4000 divided by our 1500, which equals 2.66 ohms, or thereabouts, is rounding up is 3 ohms. But the standard values for the resistors is 3.3 ohms. We suggest that you use the next largest resistor than the value calculated. For example, we calculated 2.66, but the standard one is 3.3 ohms. You can actually use several times larger. It's okay, but it will just take proportionally longer to discharge. So let's take that one step further. So let's have a look at the resistor power rating. Resistor power equals a voltage to the power of 2 divided by that resistor value. So that's 4 times the number of cells divided by a resistor value. For example, for the above single cell that we looked at a second ago and 3 ohm resistor, the minimum wattage rating is 4 times 1 over 3 equals 1.33 watts. So therefore we would suggest you use a 2 watt or greater resistor. So the methodology: you attach temporary wires to the battery terminals, you monitor the battery voltage throughout, a multimeter connected to the battery wires and set to appropriate range, you connect the resistor to battery leads, start the timer, and you monitor the voltage. Stop at 3.2 volts per cell. Do not discharge below 3 volts per cell. Stopping at 3.2 volts is a good idea. A lithium-ion battery may be damaged badly by a very deep discharge. So therefore it's a good idea to set a timer and do not leave this running and walk away. So we talked a lot about capacity, so let's have a look at understanding battery capacity. For any given battery, the capacity is given in amp hours, or AH for short, or milliamp hours, or MAH. The example on the right is a battery with a capacity of 2000 milliamps, or 2 amp hours. Therefore, this battery in theory can supply 2 amps for 1 hour before it runs out of energy. If we draw less current, say 1 amp, the battery will last longer before running out of energy. This means it can deliver 1 amp for 2 hours. If we draw more current, example would be the battery can deliver 4 amps for half an hour. And you can see that shown on the right hand side here. So don't forget to check out our other videos in this series, part 1, 2 and 3. You can also contact us if you need any help at all with your projects in China. Also, don't forget to like this video, you can share it, and don't forget to subscribe to our channel, which you can do just here. The bell symbol just on the right hand side, if you press that, gives you a notification every time we upload new content. So thanks very much for listening. My name is Paul Adams from Sofeast, and I shall see you in part 5.